All right, we got 4.2 notes. I know we went over some of this yesterday, but please watch through this again and add to the notes places that need added to. First of all, we have the side, side, side postulate, which says, you need to write this down. If three sides in one triangle are congruent to three sides of another triangle, then the triangles are congruent. So if we have a triangle, like so, in which three sides of it are congruent to three sides of another triangle, then our conclusion from this is that those two triangles are congruent to each other. Congruent means the exact same size and shape. It means corresponding sides are equal. It means corresponding angles are equal. So triangle fox is congruent to triangle lad, or foxy lady, if you will. Side angle side postulate. If two sides and included angle in one triangle, let me explain what two sides and included angle is. So if I pick any two sides in this, such as this side and this side, the angle that's included in them is the angle that they share in common. So if that is congruent to another triangle, two sides and included angle, then we can conclude from this the triangles are congruent. In both cases, the order of the letters matter. For example, F and L are in the same positions for the side, side, side postulate. Notice that F and L are both at the corners of 1 dash and 2 dash. O and A go together, they're the second positions. They're at the corners of 1 dash and 3 dashes. X and D go together, they're at the corners of 2 dashes and 3 dashes. Similarly, you don't need to add all that stuff, I'm just pointing some things out. In this other picture, C and D are both at the corner of 2 dashes and no dash. A and O both have one arc in them. T and D are both at the corner of 1 dash and no dash. As mentioned in class, angle, angle, angle doesn't work. If I have a triangle like so, and let's say those angles are 90, 45, and 45, it is possible to have another triangle with the same angles that could be bigger or smaller than this and still not be congruent, because congruent means it's the same size, but these are different sizes. So angle, angle, postulate, well, let's not say that. Let's just say angle, angle doesn't work. Looking at some examples. State if the two triangles are congruent. If they are, state why. The why is going to be one of the postulates that we just learned today. These two triangles are congruent because this side corresponds to this side, they're the same length. This side and this side are the same length, and the third sides are the same length. That is textbook side, side, side postulate. So our conclusion is those two triangles are congruent. That means corresponding angles are also congruent, which means we would know, this is not part of the question, we would know this angle is congruent to this angle is congruent to this angle, and this angle is congruent to this angle. Next picture, we only have two things marked in the pictures, two sides, but we know that these angles are congruent because they're vertical angles. The vertical angle theorem says those are congruent. So we have side, angle, side, side, angle, side. So these are congruent because of the side, angle, side postulate. Boom. Next one. Our pictures, once again, in each triangle only has two things marked. This side is congruent to this side. This angle is congruent to this angle. Well, this side here is in both of the triangles. So once again, we have a side, angle, side. Side, angle, side. So yes, these are congruent. We know because of the side, angle, side postulate. Next one, we have angle, 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 congruent to angle, angle, angle. We do not have an angle, angle, angle postulate. So no, these are not congruent. The next one, we have a side and a side. We have an angle and an angle. And we got this side here that's congruent to itself. That's a reflexive property. Congruence of segments is reflexive. So we got side, angle, side here. But we don't have this on the other one. This other one we have angle, side, side. The difference being, for the top triangle, this angle is included in the two sides, like so. In this other picture, the included angle would be this angle here, and we don't know what that is. These are not congruent. Last one, we have, these angles are the same, they both have one arc. This side here is congruent to itself. Congruence of segments is reflexive, is how we know that. We don't know any other information. We don't have a side angle postulate. So this is a big fat no. Let's make it bigger and fatter, shall we? Woo! On the flip side, we are supposed to prove that these two triangles are congruent given the facts that we have up here. So obviously the first step in any proof is to write down what's given. So segment HR is congruent to segment IH. I'm going to put that in my picture. The other fact is H is the midpoint of segment GT. So if H is the midpoint, that means that GH, that segment, is going to be congruent to segment HT. How do I know it means that? Because I know the definition of midpoint. If you look that up in your notes, we did that many moons ago, you will find the definition of midpoint is if H is the midpoint of segment GT, then segment GH is congruent to segment HT. So currently we have side, side in each of our triangles. To finish this off, we have to know the third sides are the same, or we have to know that these two angles here are congruent. And we do know that these two angles here are congruent. We know that because they are vertical angles. Angle IHG is congruent to angle THR. That's the vertical angles theorem. Now that we have side angle side, why are these two triangles congruent? Because of side angle side. Now we can say what we were supposed to prove, which is triangle GHI is congruent to triangle THR. That's the SAS theorem. That is one sassy theorem. Moving on. Triangle ACB is an isosceles triangle with a base AB. Segment CP is an angle bisector of angle ACB. Prove the two triangles are congruent. So the first thing in the proof is write down what we were given, which is already written for us. We write given. Let's interpret what these things mean. Triangle ABC is an isosceles triangle with a base angle of AB. So if this is the base, that means that these two sides are the legs, AC and CB, which means they have to be congruent because that's what it means to be an isosceles triangle. It means at least two sides are the same length. So we can say that segment AC is congruent to segment CB. That is definition of isosceles triangle. The other fact that we're given for the given, I just said given twice, segment CP is an angle bisector. An angle bisector means that these are going to be cut into two equal parts, angles 1 and 2. So we can call that angle 1 and 2, or we can name it angle ACP and BCP. But why bother when we're given angle 1 and angle 2? So angle 1 is congruent to angle 2. We know that once again because this says CP is an angle bisector. So it's a definition of angle bisector. So far we have side angle, we have side angle in each triangle. We have to either know that these third sides are the same, which we don't know. That's not the third side, that's one of the sides. Or we have to know that side CP is the same as itself, which we do know that. It's like being your own grandpa, quite frankly. Segment CP is congruent to segment CP. That's because congruence of segments is reflexive. I would also accept you writing down the reflexive property for congruence. I would accept that. So now in our picture, we have side angle side. Side angle side, side angle side. We can conclude from this that triangle ACP is congruent to triangle BCP because of the SAS theorem. It's one sassy theorem. Continuing. Properties of isosceles triangle. Before we get into that, let's get into let's get into some definitions, and you need to write these definitions down. Altitude. A segment in a triangle. Let me draw a triangle. It's a good looking triangle. A segment in a triangle that goes through a vertex. A vertex is any of the places where the segments come together. So this is a vertex, this is a vertex, this is a vertex. So you pick one of those. And is perpendicular to the opposite side. So this blue segment is an altitude. It goes through a vertex and is perpendicular 90 degrees to the opposite side. This is an altitude. That's a definition. Another definition. Median of a triangle. A segment in a triangle that goes through a vertex, once again there are three vertices, and bisects the opposite side. To bisect means to go through the midpoint. So this blue segment here is a median. I know that it bisects the opposite side because I have each of these marked as being one dash, which means that, those bottom things are going to be congruent. Median. Angle bisector. A segment in a triangle that goes through a vertex, cutting it into two congruent angles. So let's say that I want to cut this angle here in half to show that it's cutting it in half. I put the same number of arcs on both sides. This is an angle bisector. Once again, write down those definitions for each of those. They're super important. Which takes us to this theorem, and I don't think this theorem has a name. Why don't you go ahead and get rid of all this garbage, because we can do better than how that starts. Here's the theorem that I'd like you to write down. If an angle bisector cuts the vertex angle of an isosceles triangle, then it is referring to the angle bisector, is also an altitude and a median. And this theorem can be written in lots of different ways. It doesn't matter which of those we pick, angle bisector, altitude, or median. An altitude, median, and angle bisector drawn from the vertex angle of an isosceles triangle will always be all three things. So let me show you in a picture form what this looks like. So it says if segment AC is congruent to segment CB, which means it's an isosceles triangle, and if angle 1 is congruent to angle 2, we can conclude from that these blue things. That segment CP is an altitude, forms a 90-degree angle. We can also conclude from this that P is the midpoint of segment AB. So to be clear, this segment right here in blue is an angle bisector, is a median, and is an altitude if it goes through the vertex angle of an isosceles triangle. So almost finished. To solve this equation, we're going to distribute the -2. We get 5. -2 times 3x is -6x. And -2 times a -4 is a +8. Trying to combine like terms. A 5 and an 8 are like terms. That's going to give us 13. If we subtract 13 from both sides, we get -6x is -20. If we divide both sides by -6, we get -20 over -6. That reduces to 10 turds. That's a lot of turds, to be honest with you. Graphing this, the y-intercept here is 0, and the slope is -1. You don't need to show that work. I'm just pointing it out. So there's the y-intercept. The slope, we go to the right one and down one, or we can go up one and left one. Connect those with a nice straight edge. And this is the equation of the line y equals -x. Notice the slope is negative, and the y-intercept is 0. I've been asking you to label your y-intercept. Supposed to multiply these together. So we're going to multiply the 5x and 2x and get 10x squared. Going to multiply the 5x and 3 and get a plus 15x. Going to multiply a -3 and a positive 2x and get a -6x. A -3 times a -3 is -9. I misspoke. A -3 times a positive 3 is -9. These two middle terms are like terms. We can combine those together. So we get this trinomial, 10x squared plus 9x minus 9, assuming that I know how to add. Sometimes I don't. This problem here, we have some fractions. I don't care for having fractions. So I want to get rid of this divided by 4. So I'm going to multiply both sides of the equation by 4. I want to get rid of this dividing by 6. So I'm going to multiply both sides by 6. On the left, multiplying by 6 and dividing by it cancels. I end up with 4 times 2x minus 1. On the right, multiplying and dividing by 4 cancels. I end up with 6 times x. If I distribute this using the distributive property of equality for real numbers.edu, I get 8x minus 4. If I subtract 8x from both sides and then divide both sides by -2, I'm going to get x equals 2. Assuming I didn't make a mistake, that is the answer. Next one, we're supposed to graph y equals 2/3 x plus 0, which means the y-intercept is 0. This is the slope, which means go up 2. This means go to the right 3. So if I do that from my y-intercept, it's going to put me here, and here, and here. If I connect those points with a line using a straight edge, I get that line. One more, factor. It's a trinomial. It's going to factor into two binomials. If the leading coefficient is 1, which this is the easy type. We just need two numbers that multiply to get -24. Same two numbers add to get -10. Those numbers would be x minus plus 2 and an x minus 12. 2 times -12 is -24. 2 plus -12 is -10. Supposed to factor it. We've done that. Your assignment is a corrective assignment for tonight, and that is located in the tray on my desk.